Hi everyone, thank you for listening to my presentation of continual representation learning for biometric identification. Next, I will first introduce the proposed continual representation learning setting, then two new continual learning benchmarks for biometric identification, and the proposed flexible knowledge distillation method. Finally, I will show some experimental results. The classical continual learning aims to continuously learn new classes without forgetting old ones. So the model is trained on new classes in each learning step, and then tested on all same classes. However, in many biometric identification problems, like face recognition, the trained model needs to not only recognize all same classes, but also generalize well to those unseen classes. Therefore, we propose the new setting, namely continual representation learning, which aims to learn better representation that is generalized well to unseen classes. So the learned model will be tested on unseen classes. To evaluate different methods in the new setting, we propose two new continual learning benchmarks based on several existing face recognition datasets and person real ID datasets. The proposed two datasets have much more classes and images compared to those existing continual learning benchmarks. In this paper, we propose a new method called flexible knowledge distillation. Given the training data and the old model, the overall objective function to train the model includes the classification loss on new classes and the distillation loss on old classes. The classification loss is the traditional cross-entropy loss, which is calculated on the outputs or the logits of new classes. The distillation loss is the cross-entropy between the outputs of old and new models. Different from traditional distillation loss, our method has a neighborhood selection module. Given an input image, we rank the outputs or the logits of the older model and select the top k ones. Then we compute the cross-entropy between the selected top k outputs and the corresponding ones of the new model. In this way, those loosely related classes are removed, and they will not weaken the knowledge distillation on closely related classes. Therefore, this is more effective and scalable. We introduce the consistency relaxation module. We use the hinge loss when computing the distillation loss. The relaxation will provide the flexibility when learning the new model. This is a training algorithm. In experiments, we use ResNet 50 that is pre-trained on ImageNet as the backbone. Then we evaluate different methods on the proposed two benchmarks. We implement a 5-step and a 10-step continual learning on continual person real ID dataset as shown in the subfigure A and B. Experiments show that our method outperforms the competitors with a large margin. We also provided an ablation study, see the subfigure C, that verifies the importance of the two proposed modules. Similarly, we provided the results on continual face recognition. In conclusion, we propose continual representation learning for biometric identification with two large-scale benchmarks. Flexible knowledge distillation with neighborhood selection and a consistency relaxation module is proposed for better scalability and flexibility in the large-scale continual learning. Extensive experiments show that our method outperforms the state-of-the-art on two benchmarks. Thank you for listening to my presentation. If you have any questions, feel free to contact me.